Moving on, we're going to take a look at read bar graphs, two-step problems. We are so close to finish, my friends, I can taste it. The graph below shows the eye color for a classroom of students. All right, so we're going to look at greater than, fewer than, or equal to. So the number of students with brown eyes is blank. The number of students with green and blue combined. Let's see. I see 4 with green and 8 with blue. That's 12 total. Brown still has more. The number of students with brown eyes is greater than. And again, using a precise word like greater than rather than just more than or something along those lines, very important. It is precise language that will come up later on in class. Okay, we've got the number of students in each of Julia's classes. Wow, 36. That is a rough class size. After Julia made the graph, 8 more students joined her science class, bringing her up to 28, right? If 8 more students join science, it's now at 28. So after that, then math has the fewest students. Wow, chorus is really popular. Anna counted the number of hurricanes that occurred over 4 months and graphed the results. Total number of hurricanes. Oh, okay, that's again just addition, right? 3 plus 4 is 7, plus 9 is 16 total hurricanes. Moving on. The graph shows the number of vehicles built at the factory last month. How many fewer bulldozers than garbage trucks and motorcycles combined? Well, let's see. Garbage trucks and motorcycles combined looks like it is 4 and 18, so that's 22. Minus, it looks like 10 bulldozers is 12 fewer. I think I did that right. I did do that right. Excellent. Okay. Just about there. We're going to go ahead and do quiz 2, and we're just going to blitz right on through it. That's vans. That's cars. That's actually SUVs. That's vans. 25 is trucks. Lovely. Which student missed exactly 10 words? That would be Gabe. Gabe got 40 words right, which means he missed 10. Most reasonable scale. So it looks like 150 is the highest. You always want the number of students to be the vertical scale, although I guess it doesn't really matter. You can do sideways ones, so I guess it doesn't matter that much. In fact, all of these are sideways, so I guess that's fine. So 150 is the highest one, so I'm going to say the one with 150 is the highest is probably the best one. Hey, what do you know? The graph below shows the number of dogs that came to the puppy party place each weekday. That's a lot of dogs. On which day did the same number of dogs come to the puppy party place as on Monday and Wednesday combined? Well, 80 and 80 is 160, but I can pretty much visually see that Tuesday is twice as tall as Monday and Wednesday. I'm going to say Tuesday is the correct answer. Bailey Bear could not help himself and reached right into the beehive and got some honey. Wow, that sucks. We're making a graph. 10 stings on the right arm. Wow, that is absolutely just rough, buddy. 2 on the right leg. 8 on the left arm. Ow, not good. 4 on the left leg. Lots of pain. Moving right along. Okay, we are 53% of the way through represent and interpret data. We are at an hour and a half. We are doing so well. Let's go ahead and move on to line plots with fractions. Measure lengths to the nearest 1/4 of a unit. Let's take a look. What is the width in inches of the basketball? Let's zoom in. And now we are expected to remember that between 9 and 10, there is 9 and 1/4, 9 and 2/4, which is the same as 9 and a half, 9 and 3/4, and then of course 10, which is 9 and 4/4, right? So this, assuming we're starting at 0, can be measured out to 9 and 1/4 inches. You could say 9 space 1/4. That's fine, or you could convert it. If you count every single fourth, that would work as well. You would get 36. 37 over 4 would also be a correct answer. 3 and 1/4 inches. That looks like the green one to me. What is the width in inches of this tennis ball? Well, again, it's right halfway between 2 and 3. So we're going to say it is 2 and 1/2 inches. Or better yet, let's actually go ahead and put it into a fraction. Let's go ahead and say it's 1, 2, 3, 4, 5 halves, right? If I break it into halves, then there's 1, 2, 3, 4, 5 of them. So we will say 5 over 2. Also correct, just like 2.5 would be correct, just like 2.5 would be correct once we learned about decimals, which we don't know about yet. 2 and 3/4 inches. That would be the red one here. Okay. No problem. Graph data on line plots. So, do you see how this is like the same thing as picture plots? It's the same thing as dot plots. It's the same thing as bar plots. They're just using lines instead, right? That's it. They're just using lines instead of pictures. It's fine. So literally, we're just saying for 9.5, that's 1, right? For 10.5, it's 1, 2, 3, 4. 4, there we go. For 11, it's 3. Wait, I'm sorry, for back up. 10.5, it's 4, right? Yeah. And then for 11, it's 3. And then for 12.5, it's 2. I think I got that right, but I'm going to back up and just be sure. 1 on 9.5, 4 on 10.5, 3 on 11, 2 on 12.5. Done and done. Measure the length of each of these to the nearest 1/4 of an inch and plot it. So I see 2 of them that are at exactly 3 inches. And this is clever because it's kind of like a line graph, but kind of not. I see one that's 3 and 1/4 and one that's 3 and 3/4. One that's 3 and 1/4, one that's 3 and 3/4. Moving right along. On Monday, Miss Kellis. Ooh, this is the first time we have seen tally marks with the cross. I guess the cross is going this way on this one. With the cross down to show that it's a group of 5. Yes. I actually have a video in which I talk about tally marks and how they are fine for now, but they're not great for measuring very, very large numbers. Anyway, we're again just converting this into points, right? So at 14.5 inches, we need 7. 1, 2, 3, 4, 5, 6, 7. Then at 14 and 3/4, there, we need 3. And then be careful. At 15 and 1/4, we need 4. That's here. Don't put it on the 15. I made that mistake, or almost made that mistake in the last problem. It happens. Make sure you're being clear about where these dots are supposed to go. At 15.5, there's 2. That's right there. Moving along. Again, it looks like we're just, yeah. At 80 centimeters, there's 5. At 82, there's 3. At 82 and a half, 2. And at 84 and a half, there's 3. Get that right? 5, 1, 2, 3, 4, 5, 3, 2, and 3. Excellent. Fractions are not your enemy, friend. They are here to help. Read line plots, data with fractions. Let's do it. We've got some lengths of caterpillars. How many measured 4 3/4 inches? Well, let's see. That's 4, 1, 2, 3/4. I see 2 caterpillars that are 4 3/4 inches. You could also think, hey, wait a second. This is 5 minus 1/4 is also correct. You get the same 2 caterpillars either way. We have the weights of some strawberries. How many are less than 9.5 grams? Well, here's 9.5 grams right here, right? That's the cutoff point. And it is less than that we're looking for. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these strawberries are less than 9.5 grams. Let's see. The jump lengths of some frogs. How far can a frog jump? How many fewer were 6? Okay, so there's only 1 at 6 1/4. And there's 3 at 3.5. So how many fewer were at 6 1/4 than there are at 3.5? There are 2 fewer. 3 minus 1 is 2, or alternatively, 3 minus 2 fewer is 1. The heights of some sunflowers are shown below. Sunflowers are awesome. They are very tall. They are magnificently tall. They're like cornstalk tall. How many sunflowers are 3.5 feet long? That looks like only 2. And that is reading line plots with fractions. No problem. Moving right along. We got quiz 3. What's the height of this? That looks like 5 1/4 feet to me. We'll learn about inches and shit later. Let's see. We've got 1 at 2 1/4. We've got 1 at 2.5. We've got 1 at 2 3/4. We've got 1 at 3 1/4. How many are longer than 5.5 inches? 1, 2, 3, 4, 5, 6, 7, 8 of them. Again, we're just transcribing. 37 1/4 should be a 3. 7 1/4 should be a 3. 38 1/2 is 4. 38 3/4 is 2. And then 39 is 6. 1, 3, 4, 5, 6. Almost done. 5 3/4 inches looks like the red one to me. Pencil A. That's quiz 3.